I should introduce myself. My name is Kristen Weaver. I'm the Deputy Coordinator for the Globe Observer Project. And we also have Cassie Sofing, who is our webinar host this evening, but also was one of the mentors for some of these students. And I also see Peter Nelson, who also worked with some of these students from the NASA SEAS internship, which I should remember off the top of my head what that stands for, STEM Enhancement in Earth Systems Program. So we're very happy that you all were able to join us this evening to hear from some students who used GLOBE data as well as other resources to create posters and presented them at AGU, either in person, the American Geophysical Union, and either in person or as part of the virtual presentations. And so we won't take any more time on the introductions. And I think the order that I listed them on the event page was the first presentation. And what they're going to do is just give us a really brief summary of what their project was. And we'll go through all three projects, and then we'll ask some questions and have some discussion. And that'll be an opportunity for all of you to ask these amazing students about the work that they did over the last, I believe most of the work was done over last summer, if I recall correctly, but the students can explain more if they wish to. So the first presentation we'll have is from Trisha Gorusu, analyzing the correlation between the terrain and characteristics of wildfires. And just because I know some of the third group came in, we'll have Aidan Schneider and his project next. And then I think I saw Riya Tyagi and a few other people from that group come in. And so that group will be up third. So Trisha, go ahead and take it away.
Okay, sorry. My name is Trisha, and I did the NASA SEAS program while I was a junior, and my project group focused on, as you said, studying the correlation between the terrain and the characteristics of wildfires, since we were able to see a lot of the land cover in the areas some of in specific California wildfires were. We specifically focus on the California area just because that's where most of our data was available. And we try to characterize these wildfires using things like slope, aspect, elevation that we got from some other softwares. But what we use Globe for in this project is on some specific wildfires like the Dixie Fire, we were able to overlay the data of the fire and our specific points from Globe Observer that we had land cover observations for. And in those specific areas of the fire, we could see how it affected the ecosystems and some of its more specific characteristics. So on the images I have on my screen, sort of the aquamarine color corresponds to these images. And what's really great is because with the land cover feature on Globe, you're able to see images from all four of the compass directions. So although in the west and south pictures, we weren't able to see too much of its effects, in our other pictures, which are north and east, we were able to see a lot more of its effects. I forgot which direction directly corresponds with each of the pictures. However, in one of the directions, there's multiple pictures taken, which is why there's two. And our group, due to the limited amount of time we used to work on this project, we weren't able to actually make any strong correlations, but it was really helpful in helping us learn more about how these different environmental characteristics interacted with each other and how we could collect and analyze data using all these types of remote sensing platforms. That's the end of.
Thank you. And maybe we can do one or two questions. I think I'm changing my mind a little bit. Maybe if people have some specific questions for each student or student group, and then we can do at least take that while they have their slides up. Any questions for Trisha? So I guess one question is, so it sounds like one of the challenges was not necessarily having as many data points. Did you have any other particular challenges that you came across in this project?
I think being introduced to this topic relatively newly, our group was having a bit of trouble trying to figure out which aspects of the train we should really focus in on and what would be like the best way to collect these values. But after sort of working with all the different softwares that we used for this, we were able to like narrow down specific characteristics to look for that were easily collectible from reliable sources. And also, instead of focusing on a large array of fires, our group studied around 7 fires in the California area because we had to make sure they fit the criteria of like we had pictures before the fire, we had pictures after the fire. They were able to like be inside the fire perimeter.
Mm-hmm.
So those are just some of the main things we looked for.
Sounds good. Well, thank you. And people may be thinking about questions they want to ask afterwards, but let's switch over to Aidan Schneider next. And his project was on the statistical significance of local land cover measurements, comparative analysis of citizen science and remote sensing programs. So go ahead, Aidan.
All right, here, let me just share my screen quickly. All right, can everybody see that?
Looks good.
Cool. All right, so hello and welcome to my presentation on the statistical significance of local land cover measurements. So accurate land cover data can provide powerful insight into characterizing the effects of climate change, such as urban heat island effect, deforestation, and desertification. Remote sensing satellites such as Landsat 9 enable state-of-the-art land cover measurements. However, these measurements are limited by their scope. For example, Landsat 9 generalizes a 30 by 30 meter area to a single pixel. Data collected on the Earth's surface offers a new perspective on land cover characteristics through its more localized scope. So low-cost sensors such as NASA's Science and Technology Education for Land and Life Assessment, or STELLA, made granular data collection more cost-effective, and areas that may be generalized to a single pixel in remote sensing satellites data products can be observed at a more granular level through on-site data collection strategies. And STELLA offers a cost-effective DIY method for doing so. So I centered my project around quantitatively characterizing the differences between NASA Stella and Landsat 8 and 9 data. Surface temperatures were recorded hourly using the Stella sensor on 4 different types of land cover within a 500 square meter area in Reno, Nevada. The Stella sensor with the beam definition attachment was used for analysis. Landsat 8 and 9 data was retrieved for the corresponding time period through the U.S. Geological Survey's data access point. First, the statistical significance between measurements of different land cover categories taken using the Stella sensor was confirmed by approximating the average across each category's measurements as a normal random variable, fitting a curve to it, and computing its Cohen's d effect size with respect to the control of the grass category. This revealed that the differences in surface temperature readings across the different land cover types were statistically significant. The same statistical test was then applied to Stella measurements across different land cover types relative to the Landsat 8 and 9 surface temperature measurements. Once more, a statistically significant difference was evident between the NASA Stella and Landsat 8 and 9 data. The statistically significant differences in surface temperature measurements across land types aligns with our understanding of how land cover affects surface temperature, such as in urban heat islands. So this analysis shows that the Stella is accurate enough to pick up on these differences, providing valuable data. In addition, the statistically significant difference between measurements taken on Stella and Landsat indicate that there's a quantifiable difference in the perspective of each measurement that the method provides. And so in conclusion, not only is Stella precise enough to capture differences in surface temperature at a given time when measured across different land cover categories, but it provides a perspective on those measurements that most often has a 95% chance of differing from state-of-the-art measurements for the same area of interest. Now, this indicates a meaningful data gap that we posit can be filled with low-cost spectral sensors, were they to be integrated with existing NASA citizen science initiatives. To this end, we propose the following example of how NASA Stella measurements could be paired with existing globe land cover workflow. With a software-only change to sync Stella measurements with the Globe Observer Cloud database, either to store Stella measurements with Globe records or sync local storage of Stella measurements with Globe measurements uploaded from the mobile app, Stella can easily be integrated into existing citizen science workflows. I would like to express my sincere gratitude to Dr. Rustan Lowe, Ms. Cassie Soffing, and Mr. Peter Nelson for their valuable guidance and unwavering support. And thank you to Dr. Prabha Sundara Valivel, who provided the Stella sensor through a SciAC Scope Award. I'll be available for questions during the Q&A session, and thank you.
Thank you, Aidan. And I got a chance to chat with Aidan at his poster in person at AGU. Anybody have any like an immediate question that they want to ask? I think one of the things that I was impressed by, I really like the idea of taking this, of doing some analysis of this Stella tool that puts the satellite in your hand, so to speak. So I'm really excited that you did some of that work. Okay, well, if there's no burning questions for Aidan right now, let's move on to our third group. So I believe I saw, I don't know if it's Riya or Riya Tyagi, I think some other students from your group. Osiramon, excellent. Hi, is there anyone else that you've got several folks from your group. So I will just let you all introduce yourselves and take it away.
Hi, I can share my screen.
Wait, actually, I have it in presenter view. I can share it as well. I have it all set up.
Okay. Yeah, you have it more challenging because you have all of you that you have to coordinate for this, rather than the other two. We're just single, it's one at a time.
Yeah.
Go for it. Somebody. Barbara Adams.
We're not seeing a screen yet.
Yeah, I think.
There we
I
go.
see?
Okay.
Okay.
Now it's coming up. Yes, thank you.
We'll go to the beginning.
All right, hello everyone, my name is Roiba, and welcome to our presentation on uniting machine learning and citizen science for automatic land cover classification. I think you're on mute.
Sorry about that. Hi, my name's Hatham. Our project revolved around the Globe Observer app, a mobile application for gathering and sharing scientific data seamlessly. However, when labeling their data based on our polls, 73% of users felt unconfident concerning the classifications, 40% self-reported inaccuracies, 82% of users found navigating the interface difficult and tedious, and 46% were dissuaded completely from using the feature because of its inefficiency. All of that in mind, it is a reasonable assumption that the process could have used some refinement. And so our group sought out to use our collective skill set and knowledge pool in order to find a better solution.
To accomplish our goal, we wanted to leverage the wealth of data that was produced by the NASA CEAS interns and volunteers through the Globe Observer app. And so after curating our data set, we chose 46 areas of interest that we all accumulated, 1,477 land cover observations, and 5,896 north, east, south, and west directional photos.
In order to train our model, we knew we had to accurately label large amounts of data. We ended up choosing Zooniverse, a crowdsourcing citizen science platform introduced to us by mentor Peter Nelson. After uploading nearly 6,000 directional photos to our project, we gave volunteers the option to select which of the following was present: sky, land, or water. Binary classifications were then assigned to each image, as seen on the spreadsheet on the very right, and were used to train our model.
So to actually train our model, we used a few different strategies, and this was to help us first automatically classify our images as either sky, land, or water, and eventually more categories, as well as actually be able to predict the percentage of images that were sky, land, or water. So directly using our Zooniverse classifications, we trained 3 ResNet 18 CNN models, one for the categories of sky, land, and water, to achieve a classification accuracy listed on the slide. Additionally, to combat class imbalance, since we didn't have many images that contain no land, for example, we used custom class weights and sampling as well. Now, to actually get percentages of sky, land, and water, we split our image up into pieces of different grid sizes, the parameter of which was tuned. So for instance, in the sample image, you see we have split our image into 16 different grids. But we can also do more, like anywhere between like 64 and 128 proved to be pretty accurate. And then using these grids, we used our three trained ResNet 18 models to classify sky, land, and water, and then looked at the area of the grid to compute which percent of the image was covered by these 3 categories. And in total, we found that this had an average accuracy of 85%, and is something that could be used to provide some sort of default or some sort of measurement originally in the Globe Observer app to make classification and labeling of percentages easier.
Upon finishing our research, we concluded that training models on Zooniverse allowed us to accurately predict the presence and the percentages of land cover features. However, human input is still necessary to improve the quality and the reliability of the data. So therefore, it's important to combine the strengths of both machine learning models and humans.
We also want to acknowledge that these data were obtained from the GLOBE program and say our sincerest gratitude to the NASA SEAS program and our incredible mentors, Dr. San Lowe, Peter Nelson, Cassie Sofing, Andrew Clark, Dr. Erica Podest, AJ Caesar, and Aswin Syria for their continued support throughout our project.
It's the end of the slideshow.
Thank
We can answer any
you.
questions now.
Yeah, so one question for you. So it looks like your classification was, you mentioned land, sky, and water. Did you start to think about doing any classification of what type of land cover it was, or were you just focused on this sort of preliminary land, sky, and water?
Yeah, so actually that was our original goal. We wanted to be able to provide suggestions to users for the land cover feature that were available in the Globe Observer app. But due to the time that we had, we knew we had to like simplify it, simplify our goals to make sure we could accomplish something. So we decided to simplify to just sky, land, and water. And then hopefully through future research, we could provide more detailed classification features like trees, grass, things like that.
And even to go beyond in more detail, we're actually considering of using feature maps too, for instance. So that would be like taking images and pre-processing them slightly, as well as combining them with these Zooniverse classifications, or looking at like the colors in the image and looking at histograms and seeing if we can get more specific information from those. So we're experimenting with those methods currently as well, and seeing how we can combine those with our classifications.
Yeah, to add on to what Riya said, actually Zooniverse has a system to where users can kind of create shapes onto the images. And that's also one thing we explored for image segmentation. But again, with time, we thought it would be best to just simplify it down to like sky, land, and water. So volunteers could quickly label. We can get sort of like a preliminary model to test whether something like this was possible.
Thank you. Okay, so is there anyone, maybe if Siraman, if you can stop sharing so we can kind of see everybody and see if we can just try to have some conversation about this. And I have to say it was kind of, these all happened to be focused on land cover, although I know a lot of the other projects that were done by students through SEAS, many of them had mosquito components or other sorts of things. So that was just kind of a neat coincidence that there are some commonalities. But maybe, and Aidan and Trisha, if you want to turn on your cameras as well and see, does anyone want to say anything? Because you mentioned, I know the time is an aspect, but does anyone want to talk about anything, their experiences of the internship generally, things that you thought were really neat or special about it, or anything about your experience of being because these were all virtual internships, I believe, and over last summer, but anyone want to share any thoughts on that? And if anybody, and by the way, other people, if you want to raise your hand and ask questions, go ahead. I'll keep asking questions unless somebody else has them, but yeah.
I think I can go ahead and say one of like the most interesting things about the internship was, for me personally, was how much data was available to us as just like civilians to begin with. Because even though we were interns, I realized much of what we used was available to us to begin with. And the citizen science aspect of being able to use data that is openly available. And this is also kind of meshes in with the data ethics courses that we took, but being able to openly access data retrieved from satellites or from global geographic systems, it really opened my eyes to like, wow, I think almost anyone could have done this if they knew where to look and where to find it. And then another thing was, when it comes to like completing our project, I think we really learned how to move quickly, learn as we do, because time was really of the essence. And we really didn't have time to like sit down and like take courses on the things we were trying to do. So definitely moving as we go was something we also learned during the internship. So I really appreciate those experiences.
And it sounds like you adapted on the fly to the things that you thought you would be able to do something, and they said, "Oh, that's a little bit too much. I'm going to have to scale back a little bit." Anybody else want to add to that? And then I see Larissa next.
I was going to say, oh, I'm so sorry. You can go.
No, you can go ahead. Yeah.
I was just gonna say really quickly, like you said, like it was a virtual internship. So I think going in initially, I was a little like concerned about like how we would like make connections with people and like how we'd become a community. But it was so nice to see how like when we were talking about things we were interested in, like people were like opening their cameras and talking. It was so nice to see how like we all got together and we were able to have these like times where we were having enlightening conversations and things like that. So I'm glad that it was actually an experience that I can look back at and be like, you know, like I had fun and I learned, I did field work and all these things. So I definitely did enjoy that.
And Aidan, go
And
ahead.
I just wanted to second what Rayaba said. I think that being able to be in this kind of group of like-minded peers and kind of, I guess you could say, geek out about these kind of things was really fun. But also, I really enjoyed using the resources that were available to us. For example, I thought that Globe was a very valuable resource, and I actually, in my the first summer I did NASA Seas, I did 2 summers of it. I extensively used Globe in selecting my areas of interest for West Nile virus infection prediction, which I did last year with Dr. Peter Nelson, Ms. Cassie Soffing, and Dr. Rusan Lowe. So yeah, I really appreciated that opportunity.
And it seems like you can build on that, and you did project in a different area, but probably built on the skills from the first summer. Larissa, go ahead. Ask your question of these wonderful students.
All right, great. First, congratulations on your amazing work. It's just really, you've done fantastic job with all your presentation, really well presented, very well formulated, very well conducted. I'm actually very much interested in how you formed your team, how you became a community. Did you know each other before or not? And if you didn't know each other, how the process of really becoming a real team, not just a group of people who really work on some task, but what helped you to really become a team, how you figure out who is better in what tasks, how you split the roles, because we all understand there is a difference between working in a group of people and the process of becoming a really very well functioning team. So I'm very much interested in that human aspect of teamwork. Thank you.
Yeah, I can speak a little bit to this. Oh, sorry. You can go right after. But I just have a quick thing to say on this. So yeah, we came in, not knowing each other at all. And I think in this aspect of transitioning from a group of people working together to a team, I think a big part of that was experience. And just, we would call almost daily during the program. And even now we have meetings every so often as we need them to do various things, whether like put our project online or post to GitHub, etc. So I think so many of these aspects of like talking together, being online, even though we were virtual, we were still able to connect so much because of sessions that were provided by the SEAS program too. For instance, we had sessions with our peer mentors who would consistently like help us work together. So that was definitely a big step as well as being able to like contact each other for issues we had in collecting field work data and things like that too. So I think just working in so many different aspects helped us really get to know one another. And beyond this too, like all of our perspectives and thoughts were all necessary because we each brought different things to the table. And considering that, especially with the ESC program, it was very large, we all brought different data to the table. We needed every single person for data collection and data labeling. For instance, it was crazy how when we put our Zooniverse project online, within like a few hours, we got all of our data labeled because of our big group. So that was just amazing. And I really think that having all these people was what made the program so special, and we needed all of them. So
Great. If anyone would like to add, I would greatly appreciate it. But as many of us have extensive experience working in engineering and technology teams, we all know becoming a team, it takes some time and it takes an effort. So, and I was just wondering, even when you put together like a joint PowerPoint presentation, it requires some understanding and some coordination and collaboration to decide on many different small tasks, like who does what and when and how, this kind of thing. So how you manage to really figure out who is best in what and how to really utilize his or her skill to the best of their ability. Anyone would like to cover
Looks
that?
like Trisha unmuted. And she did work with a team. I don't think her other team members are here this evening, but go ahead, Trisha.
Yeah, I actually think one of the more enjoyable aspects was working on a team because I don't know, everyone on my team had a very different skill set. They did very different activities prior to joining the experience. But in the first few weeks of the internship, we were all introduced with each other, and we all chose the same theme for our project, and that's sort of how we were grouped into a research group together. And then in the later weeks of our internship, we were able to kind of get to know each other better. I know in the internship itself, they provided us these team science activities and teamwork activities that helped us get introduced with each other, figure out everyone's strengths and weaknesses so we could help each other grow throughout the experience. And I honestly feel like the mentors are also a really big part of helping us get together as a group because they helped us identify what topics we were interested in. And from there, our really large program was able to get into groups with people who wanted to research the same things. And then from there, we just sort of learned about everyone, learned about what they're good at, learned about what they're bad at, learned about their teamwork like characteristics and how they work in a team, so we're able to iron it out. And I know our team, especially, we did a bunch of meetings outside of our general internship meetings just to get to know each other better. We even spent a meeting just like hanging out just to know each other in the middle of doing our project. So we knew each other on a more personal level. Because for my group, at least, none of us were from the same geographic location. We did everything virtually.
So you were basically, we were from different locations. It's not like you all gather in the same state.
No, at least from our experience, we all gathered in different states. By now, there were a lot of people located in some areas together. But for us specifically, we just created a Discord server and used that to video chat and video call each other every 2 days or so during the internship.
Oh,
And it sounds like if the groups were formed by interest areas then and not geography, you could be pretty spread out.
yeah. No, kudos to all of you, because honestly, looking back, you might forget the numbers or whatever it is, but what you really I hope you will remember your team members, and that will probably become part of your professional network going like in the future. So yeah, and absolutely, it's very important part of the teamwork skills that you really acquire and develop throughout your internship. It's basically it's a very, very valuable skill. Working in teams. So that's fantastic. And imagine when in the future, and I'm sure you all will go to college and everything, and you will be participating in group projects there. So you will take your experience to the next level. But when you will join the workforce, it would be practically a priceless experience, because if you have experience working in teams, that's what any of us would like to hire people for work with, because, and especially if you had the chance to really work in multicultural teams, because working with colleagues from different cultures, it's really a joy, but it's also can be a challenge. And if you have experience working across cultural differences, it really makes a big different. So kudos to you. I guess it's a long way of saying how much I admire your work. Congratulations. Thank you.
Thank you too. I really appreciated the feedback.
Absolutely.
We've hit 8:30 already, or the half hour if you're not on the Eastern time zone. I guess one final thing I would throw out there, if anybody wants to share up. So, I think all of you used the Globe data and the Globe Observer app in different ways. And I know that especially the third group talked about some of the limitations and the flaws in the way that the classification is done. But I know that, Aidan and Trisha as well, you were using the app, you were using the data. Any advice or suggestions you can give us on the Globe team to make the data easier to get to improve the app or other sorts of things? This is what could we do better based on your use of the data and your use of the systems?
Yeah, I think I could add to this. I think we were a little bit harsh in our presentation looking back.
I don't think you were. I think you're right. No, I'm saying go ahead, hit us with it.
Yeah, so for our internship, we had to develop areas of interest where we, in like a 3 kilometer by 3 kilometer area of land, we took, I think it was a total of 36 observations. So we had over like 200 photos to classify. Oh yeah, those 37 points. I was close. There's one point in the center there. So we had to classify a lot of photos. And I remember like literally laying in my bed, like head on my pillow, phone to the side, and like trying to identify. And I was like falling asleep and waking up, trying to get them identified in time. And I'm like, I'm looking back. I took the photos like hours ago, right, when I was driving around. And I'm trying to figure out, wait, what is deciduous and what is evergreen, this and that. And that's kind of what was our motivation, because I think the best part about the app is that anybody could use it to help document the land cover in their area. And I'm like, okay, if we're like trained volunteers or treated volunteers, like trained in like doing the app, I wonder how difficult it would be for like just a regular volunteer to do it. So I think one thing would be, I don't even know how it would be done, but I feel like some of the classifications were a little bit complicated, like herbaceous, evergreen. It's been a while since I used that app, but some of the nuances, not nuances, but some of the more specific categories were kind of difficult to differentiate too. And especially when you're documenting that many images, you're thinking, okay, should it really be this or this? Then after a certain point, your tolerance for being very specific kind of goes down. You're just like, okay, whatever, I'm just gonna put this, right? But that harms like the data set is something I would think about, or something I would assume, right? So I definitely say a little bit more simpler identification categories, if that would even be possible.
I think something that could also help there maybe would be like a specific documentation. So something we were thinking about for Zooniverse too, because in Zooniverse, like there's this idea just generally of like being able to like label various images or like mark specific areas. And so something like a little bit of a test, like maybe like, this is because I know the Globe app itself takes a long time to make changes to. So maybe like a website or like a portal on the side that allows users to like go through like a few tests. Like for instance, it gives them a few images and asks them to classify them, and then tells them, oh, you could have like fixed this, or look at like doing this instead, to kind of try to like have each user have a more standardized perspective of how to use the labels. And I think that might be something that like, I know like having that chance to like kind of like learn from your mistakes would maybe help classifiers. So something like that possibly.
So I'm hearing simplification and maybe some practice and better feedback to users. Anybody else? I mean, Trisha, you were specifically looking at wildfire data, and I know, Aidan, what you were doing was more the comparison with the satellite data and things, but any other thoughts, or how could we make it more useful for things like looking at the wildfires or the comparisons to Stella? Any thoughts?
I think it's pretty much the same as what everybody else has been saying. Just some guides, little maybe information tabs you can open if you're unsure about what something means. A little helping hand, every now and then would definitely be great.
Okay, so maybe more guidance, kind of as you're going through it. Because I knew we kind of front loaded at the beginning. You have to do the training, but maybe some more helper features as you're going through it. Okay. Any other thoughts, Trisha, or anybody else?
I really agree with what Riya said earlier too. And personally for our group, I don't think we had any major issues with the data itself, but it was just the amount of data that was available that was our biggest constraint. which I guess just comes with popularizing the app more.
Yeah. Getting more data, because it sounded like, yeah, that's what it seemed like, that getting data in the right area where you were looking for it for these specific events. Larissa, I see your hand came up again, and then we can wrap up since we've run over a little bit.
No, it's just I'm so curious, and we're learning from across generations. So we learn tons of things from you, from interns. Don't think it's a two-way street, to be honest with you. So your feedback is absolutely priceless. So I'm sure it's just a long conversation, but I'm just curious in your take on how user-friendly app it is. And I'm sure if your task would be to develop this app from scratch, what's the user interface you would go with? Because honestly, our approach is, it's one thing. It's based on our experience that we had throughout, I don't know, our time in the industry. But your perspective would be absolutely priceless, because we're trying to really, I don't know, follow follow your footsteps in some regard to make any apps very user friendly interface. And these kind of approaches, they changes very quickly over the time. So I guess if you have any thoughts about friendliness of how user friendly the interface was, how you would change it if it's, and don't be afraid to really, it's not criticism, to be honest with you. It's rather you're helping us.
Yeah, so I actually found my notebook from when we were doing the internship, because I know I had like a lot of thoughts, but I kind of forgot them. But I found the notebook. But one thing, I really liked how in-depth the app was and how systematic the app was when it came to gathering or identifying where you were, confirming your area, and things like that. But I felt like maybe for like the general public, it would be kind of difficult to just quickly pull your phone out and then identify what's around you, right? And I think that would lead to like, not discouragement, but it kind of slows down the whole process and makes it a little bit less quick, especially when you're in the area. Because when we were doing the internship, it was extremely hot outside, right?
Yeah.
So I think, yeah, maybe if you like whipped out the phone and then like it went straight to the camera, so you can start taking the pictures, right? And then from there you got where you were, and then things like that. And I think an interface kind of, or a user interface that maybe started with that, I think that would have been really, really useful. And another thing was, I think for such a community-oriented app, I think it would have been really helpful for it to be a little bit more open, in the sense that maybe we could see where everybody else's observations were through like an app interface, right? Through like maybe a map like interface in the app. So maybe where you are, you can see little points where someone else made like a mosquito habitat, because I know that's another feature in the app, or where someone else put their own land cover observation. I know that's available through like the web viewer, but I think putting that in the app would make it, that much more immersive. Kind of like, I'm thinking like Pokemon Go almost, like how when you open the app, the first thing you see is your user, like the land around you, and then you can easily take pictures. I think that would make it much more useful. But a more of like a technical thing, one thing for me personally is that I have an Android phone, right? And we have several different lenses I can choose from, right? The ultra wide versus like the regular telephoto lens. And one thing that would have been helpful was, I know in the app, you can choose to go straight to your own photo or your own camera and upload the photo there. One thing that would have been useful is if it went straight to that native operating system camera, so I can choose the lenses, because too often I was like taking a picture, and since it limited me to just the default camera lens, which is the regular lens, I would go to my own camera app, take a photo using the wide lens, which would give like a wider point of view and include much more of the things I wanted to include. Then I'd upload that separately, right? And that kind of slowed things down a little bit. So I think if we had that within the app, I think that would have been really, really helpful. And I think, sorry, I'm just going through my notebook.
Yeah.
Yeah, I think that was it. Yeah, I think when it comes to like user interface though, like that map, like a map feature would have been would be really good and really attractive to like just the general public, right? And much easier as well.
Yeah, to see what other people have observed nearby. I see Trisha, and then Aidan, and then Riya.
Oh yeah, so not like a user interface suggestion, but I appreciated that Globe was very detailed, and so that I could put in rich data for my area of interest or whatever area I happen to be taking a measurement in. But I'd say as like a long-term goal, maybe have a support system for Stella sensor style measurements, kind of tying into my presentation. So some Stella sensor style measurements to be added to the Globe land cover report so that people can take the measurements at the same time and then pair the Stella measurements to the Globe land cover photos in the app to make the data more rich in that area.
And I think the other neat thing about the Stella unit is it does have other sensors on it. So it does things like it can do the surface temperature and other things as well that are already Globe protocols. So, and I think the team at Goddard who's doing so, I've talked to them a little bit about that. It's kind of a long process to get a new Globe protocol, but there are some neat possibilities there. And then go ahead.
Oh yeah, especially because there's also it measures electromagnetic irradiance, so you can also use it to measure, vegetation and such like that. So tying into land cover even more. So
yeah, a lot of connections to make. And I know, I'm sorry if anybody needs to leave. Of course, you can pop up. But I see Trisha's hand up and I see Riya's hand up as well. Maybe Trisha first and then Riya.
I also kind of want to expand on what Simran said. I feel like if the homepage of the app kind of had more of a dynamic look and it was easier for users to sort of like go directly to the camera. And I don't know if it was just me, but for each of the images I took, it had me like classify each of it and then put a description of that image specifically. I feel like there would have been a way to sort of condense that process to say maybe make the additional comments sort of on the same screen so you could do it all at once, or like make the process have less sort of steps to it, since this app's oriented towards citizen scientists and they generally the public doesn't want to do a whole bunch of steps. They prefer if they could just do one step and be done with it. Another thing I thought would have been cool is if instead of having to take pictures of all directions, I don't know if this is necessarily possible, but if there was any way the user could just spin their phone around them and the pictures would have been automatically taken. So instead of having to like arbitrarily figure out which directions where to make sure you're like getting all the spaces, it'd be easier to get a like more conclusive view.
Like doing a panorama, like maybe 2 panoramas or something, all the way around and then all the way around. That's an interesting idea.
Yeah.
And then Riya.
Yeah, so this is just a quick thing. So one of our fellow teams on the ESC team last year, oh my God, that's crazy. This summer, I suppose, worked on a project. Actually, this is a little bit related to like the UI. It was actually to like kind of find the optimal path to go through all of one's points. So it would be great if you could like, for instance, in Globe, put down those like, let's say you made like, we had that 3 kilometer by 3 kilometer region with 37 points. Let's say we had those coordinates. It would be great if we could put them into Globe and we could find a route that we could follow. I don't know, one team was working on this last year. But yeah, kind of like with Sarman's idea of the map, seeing if we could like find the way to go to actually move in that region. So sometimes like if you're driving with a car, it can be hard to like actually access all of your points. So maybe like suggestions and tips for that would make the process faster for people and a bit more accessible.
I apologize, my video, I disappeared on my video for some reason. Well, I don't know.
Yeah, no problem.
Yeah.
Now it looks good.
I don't know what my background, it was just my background and I disappeared. But yeah, that's interesting. I think so and one thing that we have talked about maybe is the idea to have people walk a path and what do they see above and below and get more actual like numbers instead of just the estimates from a picture, which is really hard to do and hard to do accurately. So that's something that we don't have the opportunity to do that right now, but we're hoping to do some planning for next time we're able to do some major app updates. And I see Royaba put her hand up. Go ahead.
Yeah, I was just going to say, when we were doing our internship, like we went to those locations and we kind of took our observations there, and it was kind of like a one-time thing, but some of the areas were nearby. So when I was like going on walks and stuff, I would like come back at those areas and I would retake observations just because I thought it was interesting to see changes over time. So I was thinking like maybe if there would be even like a feature where it was like kind of like a little reminder, like, hey, like you took an observation at this place, like if you want, like go back and like do it, just so like there would be more data that would again be like over time. And I feel like analysis would be so valuable with that in general. So like maybe just like, like a little cutesy reminder that's like, hey, like you took an observation, maybe go back and like see what's changed and stuff. Maybe that would be cool.
And one thing we are working on that's not exactly that, but is some more badging and some rewards in the app for if you take an observation every day, you can get a streak and things like that, which is not exactly what you're talking about, but is also intended to be kind of like a reminder and encouragement to keep doing observations. But the idea of sending people and reminding people to go take repeat observations is a good one if we could figure out how to do that. And I'm going to let Asiraman get the last word because we already got over, but I appreciate all of the feedback from everybody.
Yeah, I think you actually kind of got into it when it comes to like the rewards and like the badging and everything. But one thing I was thinking of when it comes to like motivating users to come back to the app and to continue making observations after they've initially tried it, I think once you kind of get all your observations and you send them off to the database, unless you go through the web viewer to see your observation, it's kind of difficult to see, okay, what happened to it. I feel like I've read this somewhere. I'm not sure if it's an actual feature, but being able to see like maybe any publications or projects that your images were eventually used for, I think that'd be really cool. Like maybe in like some kind of dashboard to see like what data sets your data eventually found its way into. I think that would be really cool. Then another thing, I'm not sure if this is exactly user interface oriented, but maybe motivating users to go to certain areas to take observations that are less documented, right? Maybe like giving them a goal, like go to this area and do an observation. I think that would also maybe help to motivate users to make observations in areas they may have not been to before. And I know we kind of delved into like the data ethics part of gamifying volunteering, but I think it would be really helpful to like kind of track maybe how long a user spent classifying images or going out and taking pictures so they can even use that for like volunteer hours. Because I think that would be another way to get the general public interested in doing something like documenting on Globe Observer.
Yeah. And we've done it with just kind of an estimate of, oh, you did this many observations. We estimate each one took this amount of time, that sort of thing. But actually keeping track of it would be a different step. I will point out, and Peter Nelson put this, who, you all know, but for those is also the land cover science lead for Globe Observer. He pointed out that one of the tools that we are now sort of is out there now, but just sort of got released out of beta testing is the is a directed observation. So it's the idea of you can put in a project and direct people to collect data in a particular area. And we did experiment a little bit with it with last year with NASA Moon Trees Quest, where we actually programmed it in. So if you were near one of these trees that were grown from seeds that flew around the moon on Apollo 14, if you opened up the app, it would pop up and say, hey, you're near an Apollo moon tree. You can find it at the NASA Goddard Visitor Center. Can you go take a tree height measurement and take an observation? So we have experimented a little bit with that, but it's not necessarily, customized for an individual like Reba was talking about of, oh, you take an observation. You've already taken an observation here. Go take another one. It was more of somebody wants data from this area or you're near this place of interest. Can you go take an observation? So we're working on some of those things at least. Maybe not exactly the way you envision it, but at least getting towards some of those ideas. Not some other things you've suggested. I think we aren't necessarily working on and are worth considering. But again, thank you. I realize we kind of diverted a little bit, and it's kind of my fault from what your actual research was. But we do appreciate you telling us about the work you did last summer and the presentations you did. And it's great that those who were at AGU, and I believe the third project, I think you're doing a virtual presentation next week. So anybody who was at AGU and has AGU access, the Uniting Machine Learning and Citizen Science for Automatic Land Cover Classification has a presentation, I think the 22nd. I think it's a session that's 11 Eastern. I don't remember exactly when your talk is. So if anybody has access to the AGU online, if you attended AGU, you can attend the virtual session next week. But thank you so much for taking your time this evening. And I know we went quite a bit over what I had promised you it would be half an hour, but thank you. And if you think of anything else, feedback or suggestions, be sure to let me know. And have a wonderful evening.
Thank you.
Thank you
Thanks.
so much.
Thank you so much.
And thanks
Thank
as
you.
usual, Cassie, for being host. And I think Peter already popped off, but I know that he and Rusty and others were invaluable in running the program last summer.